All right, except we're going to start at Lecture 17. So we got through most of Lecture 17. There were a couple of things I wanted to make sure we understood, starting with just these attribute value pairs. What an attribute value pair is essentially doing is it's allowing you to capture data, tagged data about a specific instance. So what we did here was we did something with houses. And what we said was, let's have a list of all the houses. You know, you guys have heard of the MLS probably. Maybe you haven't. Maybe you've never bought a house. Probably haven't bought a house. But the MLS is a listing service, and it has lists of houses for sale. And then about each house, it will have data. Well, when you're comparing two houses or when you're looking at data, there's always this free-form stuff. There's some fixed stuff. Everybody has an address. Most places will have an asking price. You know, it'll have how many bedrooms, how many bathrooms, those types of things. But not everything has, well, everything. So we can do, let's say our house is a dictionary, right? You can use curly braces or the dict command, but you can't do the dict command with curly braces. All right. So we have house as a dictionary, and let's say we want to add a specific house to it. And maybe this house has, and we can actually do, let's do this first, MLS.append house. Right now our MLS, our multi-listing service, has an empty record in there for a specific house. And we can do something like house sub asking, right, the asking price for the house is $320,000, right? And maybe we want to say something like house bedrooms is 3, house sub square feet, let's say SQFT is, let's say 1,800, and house sub HMA, homeowners, HOA, homeowners association, HOA is false. And that's probably enough for now. And if we do that, we can look at our MLS, and we probably need an ID in here. House sub ID. We would need an address. We need a bunch of things. But our ID is just going to be our unique record for it, and this is going to be H001A1. I don't know what all those mean. I just made those up. Right? H is stood for house. That's as far as I got. And now we can look at our MLS, and we have this one record in there, right? This is a list, and it's a list of dictionaries with exactly one dictionary in here now. If we wanted, right, let's take another look at an MLS. Let's do MLS2. Let's make that a dictionary instead. And this time for the dictionary, MLS2 sub, this time we'll make our IDs our keys, and we'll still put the house in. And now we can look at the MLS2, and the MLS2 is a dictionary of dictionaries, right? And it's indexed by the ID of the house, and then it has information about the house as well. And the cool thing about doing this is that all of our houses don't have to be the same. So house 2 can be another dictionary. They don't have to have the same fields. So we can say for house 2, maybe this time we're going to give it an address. We give it 110 8th Street. And we'll put an ID in there again, although if we're using a dictionary, maybe it doesn't matter. Equals, and this time it's going to be not really a house, it's going to be a college, so we'll call that C0001. And we can do something like house. There's no bedrooms at a university, so we wouldn't want bedrooms, but maybe we had classrooms. And there's probably at least 7, so we'll say 7. And now we can say, MLS2 sub, quote, C401 equals house 2. Or we could do just MLS dot append house 2. And we can look at MLS. Right now, MLS has two houses in it. Right? The first one has a bunch of stuff on there. The second one has far fewer stuff, but there's still both information about houses or about properties that might be for sale. And the same thing for MLS2. And the idea here is that you can enforce consistency on your dictionaries if you want, or you can let them be freeform. And, basically, this becomes, a freeform or a unstructured dictionary where you have the fields that you have and you don't have the fields you don't have. And you can enforce consistency by maybe requiring everybody to have, a square footage or an ID. Certainly everybody should have an ID. And then you can go from there to kind of, oops, you know what? I added classrooms to house instead of house 2. That's okay. My house has 7 classrooms, apparently. All right. So that's just the idea of this attribute list or attribute value pairs, right? The attribute is the key for the dictionary, and the value is, well, the information you want to convey. And it's a very, very common usage of dictionaries. I also wanted to point out this accessing APIs. We talked a long, long time ago, maybe 3 or 4 lectures, about this ability, when we were talking about parsing, about the ability to extract data. The ability to parse out data. And what we said was that parsing was just taking the data generally in a string format. We're reading from a file, so we're reading a string at a time, and converting it to usable data. So here's a little example using dictionaries and URLs. So this URL live request allows us to go out and interrogate on the web. And JSON is a format. So if we put in a URL, and this is just a URL that asks us to find from StreetMap, well, it's actually searching for Troy, New York. And you should be familiar with this. This just opens up the URL, makes it look like a file. And once we do that, we can read whatever content this URL wants to provide us, giving this input string. And then down here, well, that's where we get kind of funky. So let me run this. And when I do, we can look at a couple of things. The first thing we probably want to look at is we want to look at the URL, right? It's just a search string that we're giving to nominatum. That's OpenStreetMap query answerer, essentially. And the question we're asking is, give me information on Troy, New York. So we open up. F becomes essentially a file we can read from. Then we do a raw content, and we look at raw content. And when we look at raw content, what we see is raw content looks a lot like this. But the important thing is it's this B quote. And that means that it's a binary string instead of just a string. So if we look at B sub 0, what we get is, if we look at raw content sub 0, B was the first character of that. You'll see that that's not the first character of that. In fact, what is this character 91. And the second character is 123. Well, this is reading this as a sequence of binary characters. So that's actually the value, the ordinal value of the square bracket and the ordinal value of the curly bracket. If we want to actually look at this as a string, we have to decode the binary string to a regular string, and that's just, what is it, raw content, should be over here. Yeah, raw content.decode UTF-8. Let's just throw that into a string. This tells it to decode it, make it into a regular string instead of one of these extended binary strings. I'll just put that into string. And if we look at string now, it looks, you know, there's no B in front of it, which is good, right? And now we can look at it, we can say string sub 0, and instead of the 91, we get the square bracket, and instead of the 123, we get the curly brace. And if we want to ask for what the actual byte value is, we can kind of do this, and this should give us the same thing that the B string was giving us. So the first, you know, string sub 1 is the curly brace that has ordinal value 123, and 0 is the square brace that has ordinal value 91. So all we're doing here is we're kind of coming in. So up to this point, this sub-expression on line 16, we're just taking the data that we read from this URL and we're decoding it into a regular string, and it still is essentially a string, and we can look at this, right? There's string data in there. There's a whole bunch of nested curly braces and square braces, but the whole thing is just a string. There's no additional meaning on this. This is just a sequence of characters. So now if we want to impose meaning on this and parse this out, knowing that it's a JSON file, and knowing it's a JSON file, JSON loads takes a string in JSON format, and what it does is it converts it into, it parses it out and puts it into code. So if we do the JSON loads here, what we'll see now is that instead of being a string, what we actually have is a list of dictionaries, essentially a list of attribute value pairs. And that's exactly what we put into content. So now we can look at content as a list of attribute value pairs, right? So content is just what we saw before. Let me make this as big as possible. Content is what we saw before. Content sub 0 is Troy, New York, right? Place ID, it's a node, it's an OSM ID, there's a bounding box for it. The display name is Troy, Rensselaer County, New York, United States of America. You know, so if we look at content sub 0, sub display name, what we're doing is we're taking the first record. This is like our MLS example. We're taking the first record, that first record in our contents list is an attribute value pair, and we can begin querying it for different fields, display name, for example. And we can do this for all of the fields. So we can come into content sub 1, right? And this is Troy, 675 Hudson Street, Meatpacking District. It's still in New York. If we look at it, we can do type, I think that's a bar. Not because I've ever been there, but because I was playing with this data a little earlier. So that's a bar called Troy on 675 Hudson Street in the Meatpacking District. And we can also look at content 2 as well. And let's see what content 2 is. Its type is a restaurant. And let's see what content 2's display name is. Maybe it's a nice restaurant. We'll want to go there. Highland Boulevard. It's called, I guess the restaurant's name is Troy, Highland Boulevard, Staten Island, Richmond County, New York. So this is just a couple of things. One, it's showing you how to parse JSON. It's showing how to get strings from the web, parse it in, if it comes in as JSON, parse it into a sequence of dictionaries and lists and attribute value pairs. And it's also showing you kind of how these attribute value pairs are actually used. I'm not sure whether this is a consistent list. I didn't go through everything, but you can see that, yeah, it looks like it's probably consistent. So this is a consistent attribute value pair. I think that all the fields that we have in any of the dictionaries in the list will be the same. But, then again, maybe not. Anyway, that kind of wraps up where I wanted to go with Lecture 17. So I guess we can start off. Any questions? Let's see.
I have a question.
Sure.
So basically content is a list of lists, but each list has a dictionary.
Well, it's a list of dictionaries. It's not a list of, it's a list of dictionaries, right?
Yeah.
Yeah.
But I mean, like the brackets, like 1, so that'd be dictionary 1.
No, so, right, when we're looking at raw contents or string, let's look at string, right? Then we have just this string, and it has a bunch of, different characters in it, right? When we get to contents has now been parsed out. So wherever it sees a square bracket, it's going to build a list. Wherever it sees a curly bracket, it's going to build a dictionary. Okay, so if we look at content. Yeah, content is a list of 3 dictionaries, right? So here's the entry at index 1.
So it's JSON, like JSON dot is what's making this possible.
Yeah,
so
JSON. JSON is a module that has some JSON utilities, including the load utility, which allows you to parse JSON files into actual Python data structures, like lists and dictionaries and strings and such.
Right, so it basically made it so that in content you have different dictionaries that you can just call, and then the second bracket you could just call the specific part of the dictionary.
Yep.
That makes sense. Okay.
All right. There's a question, raw or curved score tonight. It will at least be the raw. It will likely be the curved. All right, so let's get started with classes. So now we're going to leave kind of dictionaries behind. We've now got them in our toolbox. We can use them. We will be using them as part of our classes. But now let's look at classes in general. And if you want to think about what a class is, we've been dealing with data. We've been passing data around. So for example, here we have, contents is a list of dictionaries. We have MLS, which is a list of dictionaries. We have MLS2, which is a dictionary of dictionaries. And these dictionaries have these different data structures, lists as well, have things we can do with them. So for MLS is a list. Right, so there's things we can do with it. There's methods we can call. We can sort, we can reverse, we can sort a list, we can remove values from a list, we can pop, insert, extend, etc. So there's all sorts of things we can do with a list. And the list carries along data, right? So if we look at MLS, the data MLS carries around is, well, this particular MLS carries around 2 dictionaries with it. So this ability to associate data and then methods that operate on the data is what is kind of at the heart of object-oriented design concepts. You have data, the stuff you're stuffing into your list, and then you have methods that allow you to act on that data in an intuitive or an abstract kind of way. So for a list, what we've done is we have data, which is the members of the list, right? In this case, two dictionaries. And then we have things like MLS dot append, right? Where we can put new elements in. I'll put in an empty dictionary just because I don't have any more things that I can think about that I should put into a dictionary. Right? So append is a method that allows us to modify or access the data in our abstraction of what a list actually is, right? And then if you think about it, what a list is, it's an ordered, right? You have the 0th element, the first element, the second element so far. So everything has an order. It has a place of data, ordering of data that we can have random access to, and that can be extended with the append operation, or, for example, made smaller using things like pop and remove. Dictionaries are not hashable, so they can't be used as keys, but they can be used as values. And a dictionary can contain multiple keys. In fact, the dictionary in general has multiple keys. I keep going to the wrong. Kristen's answering all those. She's doing a good job. I should just let her go. Okay. So, what we want to talk about